This is a video guide for tutorial 3 using R for data analysis, working with RStudio. So I have R version 3.6.1 installed in my computer, and we will start as always by setting the working directory, in this case to the open file pane on the right. This sets our work environment to the folder where I have all the data sets used for class. These include the HT4R code script, which you can open and try to run. So the first line of code is to set up the packages required, and as you see, I'm getting an error message because with this R version, this code is no longer in use. And the recommendation is to go to Bioconductor and install more modern or the latest available R version and the latest available Bioconductor package that runs with it. So if you look at the text here, the current Bioconductor version is 3.12, and it should work with R version 4.0.3, whereas I still had the 3.6 version. So if this happens to you, you have to take a step back and start by installing the latest release of the R version, which will be automatically incorporated by RStudio. And then you run that code to install the latest version of Bioconductor. So I'm following the tutorials, and you get the information of the links to go to download the most recent version of R. These are links to the CRAN website, from where you can choose multiple versions of R depending on the current operating system that you are running. So you can go to the CRAN mirrors, and you have lots of options, but I'm going to choose the first one that is supported by RStudio. And here you can see the option of downloading the macOS version for R and the link to the R 4.0.3 package that will be compatible with my specific operating system. So now you will see the basic process for installing R in Mac, which is going to be a little bit different from whatever you would be doing in Linux or Windows. And basically, I just have to open the package, give my permissions, and then click install on the desired location. So usually, obviously, you get this basic password request. Once this is overcome, the installing process will take place, and it really should be rather quick. In the meantime, you can close RStudio and then get back to it, and we will see whether RStudio has switched from the R version 3.6 to the 4.0. Okay, so the installation is complete, so we can move to the next step, which is reopening RStudio and seeing if now we can proceed to installing the latest version of Bioconductor. The version is now 4.0.3. I'm getting an error message that I'm missing the ggplots2 package on top, so I will take advantage of this message to install this package, which is really convenient for plotting graphs. Whenever you are installing, you will see in the console all these red lines moving on their own and giving you information of what is happening and how the install is going on. And then once it's finished, you'll get to the command prompt, and you know that you're ready to go. So as we've discussed before, in RStudio you will have the upper window showing the files that you have opened, and the lower window showing the console, and to the right your environment, either of variables or of files. So now I'm going back to find the Bioconductor page where the instructions for installing the latest version of Bioconductor are available, and basically the idea is just to copy and paste these commands into the RStudio console, and these will immediately call the latest Bioconductor version. Okay, so I just copied it, and now I'm pasting the full command set and clicking enter, and it's basically doing the installation of Bioconductor version 3.12. So here the software is identifying some old packages that need to be updated, and you can choose whether you want all, some, or none. And in this case, you should use the letter A, S, or N to define your options. So I'm going to type A because I want everything to be updated. And then the version of the latest version of Bioconductor will be installed. So now we already have updated our software, and we can start running the commands for the tutorial, but the original error message that we got just said that the previous command that we were using to install packages is actually currently deprecated. So you need to use a new install system that is based on BioC Manager rather than the former BioC Lite, which I still had written down in last year's tutorial, and in this year obviously it isn't working. So the actual command lines to produce the installation we'll figure out by looking directly at the packages. We want to install 3 packages. Let's see if they still exist and if there are updated versions. So we can search for EdgeR in the search box, and yes, the first hit we get is EdgeR, and that takes us to the package page where you can find a description of how to install it, and also how lots of information, documentation, and a specific set of documents called a vignette. So the current command for installing Bioconductor packages is the one that I'm going to type now. And actually, to run this tutorial, we need to install 3 packages, EdgeR, BioBase, and GeneFilter. So let me just comment the previous commands so that they no longer run, and make the new versions of these commands. The code is exactly the same, and then you just replace the package name. So BioBase, GeneFilter, and EdgeR, we already have it there. And if you go and check in Bioconductor, all these packages are still available and have been updated to run with the current version of R and Bioconductor. So I'm going to select the 3 commands I want to run, and then click in Mac Command Enter. And as you see in the console window, installation has immediately started. The BioC Manager command is running for BioBase, and then you get all the red lines telling you how things are proceeding and coming to an end quite quickly. And so in this way you have packages that you require already installed in your R environment, but then you need to call these packages by using the command library, BioBase library EdgeR, library ggplots. And this brings us finally into a position where we can actually start running our R tutorial. So you can try some of the commands here. The first one is to import the data. If you're running a command you don't know what it is, you can start by a question mark, and in your right side pane you will directly go to the help page where you see the description and the comments that you can use to run the command. So you have prior suggestions here, and I'm trying to import my data table into a variable called data, but you can see that we got an error message stating that this file cannot be opened because it's not there. And I just realized that I hadn't set the proper working directory. So the work environment is in a totally different directory, and so I just navigated my way there, and I'm going to the session option, set working directory to the file pane, and this will run the command set working directory, and you can now see that you are in the directory 2021 tutorials where I have the required data sets, and this allows me to run again the command read table into the data variable, and in your right side you can actually see the data variable showing up. It's composed of 8 variables and 1,000 and something observations, and you can actually open it. And then you can start running the different commands to try them out. So the command head to look at the first lines of the data, the command dim to see how your table is organized, how many columns, how many rows. A very simple function, which is a correlation analysis, that will generate a table with 8 columns and 8 rows showing the actual correlation between samples. So identical samples will have a correlation of 1, others will vary according to the distances. And this table can then be used to produce a heat map that shows how the samples relate to each other. And whenever you give a command to run a plot, the plot will appear on the right side of your panel, and you can actually export it onto a figure. As you see, the plot readjusts automatically to the size of the window, and we can see all the samples we have in our data set and how they correlate to each other. And here we can actually export this to an image file or a PDF file. We can define the size of the file that we are interested in, and then just save it as an image, which you can use in your reports or papers or whatever. In addition to a heat map plot, you can also plot a multi-dimensional scatter data plot, which is a kind of principal component analysis that identifies different dimensions in your data set. And again, here you can export this as an image, but it's also cool to analyze that you basically have 3 groups of data separating within the available plot space. I'm going to generate a square plot here by defining both width and height. Yeah, I failed this one. The width wasn't reset, so let's make a square plot with 1,000 pixels of width and height. And you will see that we have 2 peculiar samples that really are concentrated on the left-hand side of the plot and vary a lot on dimension 1. And these samples are labeled 1. And then we have a vertical separation of samples that is establishing a difference between the S samples and the NS samples. Okay, so the rest of the tutorial moves on to analyzing the data set, but first you might want to consider excluding the S1 and NS1 samples because they're behaving kind of oddly, and by this you can do a subsetting of your original table data set using the brackets option to subset as in the command that is presented there. And you can see now that you generated a smaller table that only contains 6 variables in opposition to the 8 that you previously had. So we can look at the dimension of this data set, and it has the same number of rows but a smaller number of columns. We can now again run the Y correlation, the correlation function, and in this turn I'm using the Y variable to assign it to, and then do a heat map and do a dimensional plot just as before. And here you get quite a distinct result in which your data set and your samples are now clearly organized in 2 branches, one that corresponds to NS samples and one that corresponds to S samples. And this is what we call exploratory data analysis, because if at the start of your study your samples do not correlate with their biological origin, then something really serious must be going on, and there's most likely a technical problem in sample generation that you need to sort out and eventually remove sample outliers before you proceed with the analysis. And this was the case of what we were seeing with the samples number 1, which were clustering together rather than aggregating with their specific biological type. So then this part of the tutorial will do the differential expression analysis using EdgeR. The first thing you have to define is the groups of samples, which samples belong to one type and which samples belong to another type. Then you define a matrix with a given design, and you apply a statistical model, a linear regression model, to your data set so that you can actually perform the analysis. And then finally you can use this top tags command to generate a list of differentially expressed microRNAs. And this list it's actually a table composed of 5 columns. The logarithm of base 2 of the fold change, which tells you what is the differential expression of your target gene between 2 conditions. The logarithm of the counts per million, so basically giving you an expression level of the gene. And then in the end, the statistical measurements of your analysis, namely the adjusted p-value showing you the significance of, the p-value showing you the significance of the analysis, and the false discovery rate, which is basically an adjusted p-value. So here I think the analysis is being performed with the second data set, which is smaller, and you can see that you're getting a much higher statistical significance in the analysis. And finally, some tricks on how to retrieve original expression data from the table that you imported. For example, in this case, how do you find the expression levels of microRNA 155? And so this was basically just a very quick overview of the R tutorial and showing you how to solve some problems regarding it.